system software and application software. Software basically together this. First one system software, next one application software. Yes, what is system software? Anyone idea? Yes, maybe some working professionals. Yes, tell me guys. So what is your idea about system software? Anyone? System software and application software. What is system? Very basic things these are. Anyone idea about system software? What is system software? System software. System software. It interacts with the hardware components. System software. It interacts with the hardware components. It interacts with the hardware components. It interacts with hardware components. Example ways. Operating system. Operating system comes under this category. Operating system. Okay, system software. It interacts with hardware components. A system software, it interacts with hardware components. Example ways. Example ways. Example ways. Okay. Yes. OS something like Windows OS, Linux OS, Mac OS, all the operating systems. Operating systems interacting with hardware components. So these are system software. Our OS is a system software. Next, application software. Application software. So what is application software? See, application software for the purpose of application development. So for the purpose of application development, 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 application software, application software for the purpose of application development, for the application software for the purpose of application development, applications, apps. Okay. Yes, application software for the purpose of application development. See, applications. Yes, in our real life, we are using many applications. In our day-to-day life, we are using many applications, right? See, in our mobile, there are many applications. Okay. In your mobile, there are many applications, right? So, which is mostly used application in your mobile? Tell me, guys, which is mostly used application in your mobile? Yes, which is mostly used application in your mobile? No one answering? Yes, WhatsApp. Harish, good. WhatsApp. So WhatsApp is a mostly used application. WhatsApp. So WhatsApp. Okay, maybe Facebook. Okay. Yes, maybe yes, GPay. So Google Pay. So Phone Pay like this. Okay. Yes, next Twitter. Okay. Yes, Insta. So Insta. Next online shopping applications. Online shopping applications. Okay, next banking applications. Banking banking apps like this. There are different kind of applications, right? Yes, to develop these kind of applications, maybe zoom app, like there are many applications. Okay, like healthcare management. Okay, healthcare domain, insurance domain, banking domain, like that there are different domains, different applications, right? To develop such kind of applications, we need some software. To develop this kind of applications, we need some software. That software is application software. So application software for the purpose of application development, this kind of applications, to develop this kind of applications. Okay. Best example for the application software, Java. Java is a mostly used application software. Compared to any other technology, Java is a mostly used application software. Java. Yes, even C and C++ also application software. Python is also application software. Even .NET also application software. .NET also application software. Okay. Yes. Next, .NET databases, also application softwares. Suppose Hadoop is also application software. These are all the application softwares. Okay. So there's some examples of application softwares. Okay. Yeah, there are many application softwares we are using here, like languages. There are many languages. It's application software. Okay, right? Some packages like ERP packages like Oracle ERP, SAP ERP, like that. Like some tools like testing tools, big data tools, AWS tools, DevOps tools. Like there are many things we are using. Okay. Yes. More than 100 technologies. More than 100 technologies we are using. So which is exactly application software? Which is exactly application software? See, except OS. Only OS can interact with hardware components. OS is a yes system software. Only OS can interact with hardware. Others cannot. Others cannot. Only OS. Only OS is system software. So except OS, remaining all the technologies, whatever things we are using, all are application softwares. Okay. See, except yes, except operating systems. Okay. All are. Okay. Yes. Rest of the technologies, all are application software. All are application softwares. All are application. All are application software. Okay. All are application software except OS. So OS examples. So what are the examples of OS? Windows, right? Windows is a OS. Okay. So Windows is a system software. Next, Linux is a OS. It's a system software. Mac OS, right? System software. Okay, right? Next, mobile applications like iOS. Okay, iOS. And next, Android. So these are operating systems, right? So these things are system software. These are system software. Systems of except these things, remaining all are what are the technologies we are using. What are the technologies? All technologies comes under application software only, except ways. Except ways, remaining all are maybe AWS tools, DevOps tools, okay, maybe testing tools, Hadoop tools, big data tools, okay, maybe different language like Java, C, C++, Python, these things here, package, some ERP package, all are application softwares. Everything is application software except OS. Except OS, remaining all are application software. It's clear. Except OS. Except OS, remaining all are application softwares. It's clear. Okay. Yes. Your class documents. Yes. Today's session. Yes. Introduction to software. Yes. Very clearly prepared in the document. I'll share this document. This document for you only here. This document. Yes. 850 page doc. Complete core Java. It's 850 pages. Okay. Software is a collection of programs such as C, C++, Java, and all this, right? Software basically two categories. So first one, system software. Next one, application software. System software and application software. See, system software, it interacts with the hardware components. Example ways. Application software for the purpose of application development. Example apps, applications examples. WhatsApp, Facebook, online trading applications, banking applications. Example for the application software, C, C++, Java, .NET, ERP package, and others, right? See, except ways, except operating systems, remaining other application software. Okay, same thing it's there in document here. In the just you can follow document here. So what are things explained in notepad? Okay, what are things are explained here? Everything is there in document here. Just you can follow documents. Just you follow this document here. So not necessary to write any running notes. Running notes is not necessary. Just simply follow the document. After finishing class, just read the documents. Yes, you can remember forever. Okay, right? Okay, fine. Now, see about waste. Let us see about waste. Operating system. About waste. Yes, about waste. About operating systems. About operating systems. About waste. See about operating systems. About waste. Yes, what is exactly waste? Yes, some question for you guys. Some question. Some question for you guys. Some question. Some question. Can we run any program without waste? Yes, without waste. Can we run any program without waste? Very simple question. Can we run any program without waste? No. Answer is no. Good. Yes, no. If no waste, no computer, first of all. Without waste, no computer, right? Okay, without waste, no computer. Okay, no, we can't. So waste required compulsory. So what is exactly what is operating system? So what is operating system? What is operating? Let us see about waste here. Okay. So before going to waste, we have one more concept. See, can we run any program without waste? No. Answer is no. Yes, we have one more program like bias program. Except bias. Except bias. Except bias. Yes, except bias to run all programs who is required. To run all programs who is required. Who is required. To run all programs who is required. Who is required. Okay. Except bias. Except bias. Yes, except bias. Except bias to run all programs who is required. So what is exactly bias? Anyone guess? So what is bias abbreviation? What is bias? Yes. Anyone can you tell this? What is bias? Yeah, resetting system, formatting system. No, no. Bias is different, resetting system is different. What is bias? Bias using for the booting purpose. So bias setup. So by in system there is a bias setup. As per bias setup only OS will boot. As per bias setup. Okay. That is a hardware setup. Bias is a hardware setup. So what is exact bias? So bias. Anyone can you abbreviate bias? Bias abbreviation. Bias abbreviation. Okay. So bias stands for basic. Yes, basic input. Basic input. Basic input. Basic input. Sorry. Bias stands for basic input and output system. Basic input and output system. Basic input and output system. Bias stands for basic input and output system. Bias stands for basic input and output system. Okay. So here bias is a hardware. Bias is a hardware program. It's not a software. Okay. Bias is a hardware program. Is a hardware program. Bias is a hardware program. Yes, it is a chip level program. It's a chip level. It's a chip level program. Okay, it's a chip level program. So bias is a hardware. Bias is not a software program. Yes, it's a hardware program. It's chip level program. It's electronic program. It's electronic program. So bias is a hardware program. It's a chip level program. Let me show the bias in our system. Bias. 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 Bias image. See that. So this is bias. In your system, here's a bias. So this is bias chip. So bias chip with motherboards. So this bias chip contains one program, hardware program. So hardware program, right? Hardware program. See, this is bias setup. This is all this bias setup. Okay, it's a hardware setup, like date and time setup, hard disk type setup. Okay, next booting device. Is it a hard disk or USB? From where? So it's completely a bias setup. That is bias setup. Okay, it's a bias setup. Okay, so this is bias. The setup inside the disk, inside the bias chip. So this bias chip contains one bias program. Okay, so once power on your system, so first of all, power goes to bias chip. Once power on your system, first of all, power goes to bias chip. If this bias chip contains one program, that hardware program, that program is responsible to boot your OS. So this program is responsible to boot your operating system, booting operating system. Okay, booting OS, right? Yes. So your bias. So your bias is responsible. Bias is responsible to boot operating system. To boot operating system. To boot operating system. So to boot operating system. Okay. Yes. Bias is responsible. So bias is responsible. Bias is responsible to boot operating system. So what is booting exactly here? Booting ways. What is booting here? Booting. Booting is a process. Booting is a process of loading. Loading ways from hard disk. Loading ways from hard disk. Hard disk to RAM memory. Hard disk to RAM memory. Hard disk to RAM memory. So booting is a process. Booting is a process of loading ways from hard disk to RAM memory. See, so once you power on your system, first of all, power goes to this bias chip. This chip contains one program. That program loads the OS from hard disk to RAM memory. See OS, where is OS? See inside of disk. Here is a Windows OS, right? It's a Windows OS. Here is a Windows OS. This way is storing in the disk. Way is storing inside the hard disk, right? So once you power on your system here, so once power on system, that BIOS program simply loads the OS from the hard disk, from C drive. Here hard disk, right? Hard disk to RAM memory. Hard disk to RAM memory. See here this OS, Windows OS, right? This is running inside the RAM memory. Yeah, this is running inside the RAM memory. This way is running inside the RAM memory. Okay. So you can loading OS from disk to RAM memory. So OS always running in the RAM memory. Now this OS is responsible to run everything here. All are running on top of OS only. All programs. Maybe C programs, C++, Java. Yes, maybe yes. Like a Zoom application, yes, Word document, Notepad, okay, Word, okay, all of these things, yes, maybe browser, okay, all of these things running on top of OS only. So first of all, once power on your system, first of all, once power on system here, that power goes to BIOS chip here, BIOS chip. So this BIOS chip contains one BIOS program. That BIOS program, that BIOS program loads the OS into RAM memory. So once loaded, your system is ready. Now my system is ready, right? My system is ready. So this OS is running inside RAM memory. So this OS is running inside the RAM memory. So this OS is responsible for everything. Now OS is responsible for everything. Okay, fine. Okay. So you can, can we run any program without waste? No. Software programs we cannot run. Without waste, we can't run any software program. All software programs running on top of OS. All software programs running on top of OS. See, except BIOS to run all OS required. So BIOS stands for Basic Input and Output System. So BIOS is a hardware program. It's a chip level program. It's a chip level program. So BIOS is responsible for booting operating system. Responsible to boot operating system. What is booting? Booting is a process of loading OS from hard disk to RAM memory. Okay, right? So OS is running inside the RAM memory. Always OS is running inside the RAM memory. Even programs are also running inside the RAM memory, right? Okay, fine. Now what is OS? Let us see about OS. So what is operating system? So topic is about operating system. So what is OS? So what is operating system? So what is operating system? So what is operating system? Let us see about OS. So what is operating system? So what is operating system? Let us see about OS. Okay. Yes. See your computer. Yes, in computer there are different layers in your computer. Yes. In your computer, here there is a hardware. Hardware. On top of hardware, OS running. Operating system. On top of hardware, OS is running. On top of OS, different programs like C and C++, maybe Java program, maybe Python scripting. Yes, maybe databases. Yes, even to run the MS Office also OS required. MS Office. All are these things running on top of OS. So you get hardware. So this is your computer. In computer, there are different layers. First, hardware layer. On top of hardware layer, OS running. On top of OS, all the programs running, right? So all these programs are application softwares. All these are application softwares. Application softwares. All these are application software. 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 So all these are application software. So here it's a hardware. On top of hardware, this is a OS. On top of OS, so here application software is running, right? Okay. Yes, all are running on top of OS. See OS. So OS is a system software, right? It's a system software. OS is a system software. So this is system software part. System software. Okay. So this whole thing is a computer. This whole thing is a computer. This whole thing is a computer. Okay. See, computer where. See, at the beginning we have discussed computer where there is a hardware and software. Hardware and software. Hardware and software. See, hardware. These two layers is a software. There is a hardware layer on top of which software layer, right? Hardware and software. So this whole thing is computer. Computer. Here there is a hardware. On top of hardware, software running. Yes, in software there are two things: system software and application software. System software and application software. See here, systems or see this system software and application software. So first of all, hardware, on top of it, system software layer, on top of system software, all the application software is running. So this is computerware, your computerware. So hardware, yes, on top of hardware, software. In software, again, two layers, system software layer and application software layer. Same thing here discussed. Okay, system software or application software. Okay, fine. No. Okay. Now here OS. Let us see about OS. What is exact OS? See, on top of OS, all programs running. Maybe C program, C++, Java, Python, database. All of the programs running on top of OS. All these programs running on top of OS, right? All these programs running on top of OS. All these programs running on top of OS. So OS giving platform. Here operating system giving platform. So here OS giving platform. OS giving platform. Okay. On top of OS, all these are running. So here OS it's giving platform. OS it's giving platform. Okay. This is working like a platform. On top of OS only all are running. So OS here acting like a platform. It's acting like a platform. So what is OS means a platform. OS is a platform. So what is OS means? Yes, it is a platform. It's a platform. It's a platform. Yes, it's a platform. It's a platform. Yes, we can run, where we can run all the application software, all the application software, all the application software. It's a platform where we can run all the application software. So here OS. So OS acting like a platform. It's a platform. So OS is a platform where we can run all application software. Yes, that application software, maybe C program or Java program or Python. Yes, maybe MS Office, maybe Notepad running here, even Zoom application. Yes, all tools or packages, all are running on top of OS. Everything running on top of OS only. Maybe languages, maybe some tools, maybe some whatever technology we are using nowadays. All technologies, all are running on top of OS. All are running on top of OS only. So OS is giving platform. So here OS is working like a platform. It's a platform. So OS is a platform where we can run all the application software. Right? See, not only platform here, not only platform. Suppose, for example, here, for example, C program or C plus Java. These programs generating some output. Yes, output. These programs generating some output. So output of all these programs, first of all, deliver to OS. Okay. Yes. So output of these programs, first of all, transfer to OS here. Output of all the programs, first of all, transfer to OS. After transfer to OS, finally, yes, deliver to output device. Next, deliver to output device. Okay. So first of all, output of all the programs simply goes to yes, OS, and then finally deliver to output device. Deliver to output device. Deliver to output device. Suppose input data from the keyboard. Input from the keyboard. So keyboard data first of all goes to OS. Keyboard data transfer to OS and then transfer to these programs, right? So between application software and a hardware layer, there is a OS. There is a OS. So OS is like a mediator, something like a mediator between application software and hardware components. It's a mediator. It's a mediator between application software and hardware components. So mediator means interface. Yes, exactly. Terminology is interface. It's interface. Yes, it's an interface. So OS, it's an interface. It's an interface. It's an interface. It's an interface between. It's an interface between application software layer. It's an interface between application software and hardware components. Application software and hardware components and hardware components and hardware components. Okay. Yes. So OS is an interface. OS is an interface. It's an interface between application software and hardware components. Clear? So what is operating system? So what is OS? It's a platform and it's an interface. It's an interface between these two. Next, one more important point. In Java perspective, I'll tell you one important point. Instead of OS, this is a library. This is library. In every way there is a library. So in every way there is a library. Every way contains library. That library contains yes inputs and output functions. That library contains input output functions. Okay. Every ways has its own library. That library contains all the input output functions. So this library is responsible to communicate between application software and hardware components. Inside the OS, there is a library. Library, that library is responsible to communicate between application software and hardware components. Okay, so every OS, yes, every OS has its own library. Every OS has its own yes. Windows has its own library. Linux has its own library. Mac has its own library. Remember this point. Java perspective very very important. Okay. See in Java we are going to discuss about independent of platform features, right? Java is independent of platform. How Java made us independent of platform for this? That time we are going to discuss about library concept. Library. OS library concept. Okay. So every OS has its own library. Library. So library is to communicate. Library to communicate. To communicate. To communicate between application software and hardware components. Okay. Every OS has its own library to communicate. To communicate between yes application software and hardware components. So inside of OS there is a library. So here OS utilizing this library. OS utilizing this library to communicate between these two. Right? Yes, apart from this, one more important point. See, C program, Java program, Python, all the programs, right? Yes. So before going to run these programs, first of all, these programs links with OS library. These programs links with OS library. These programs links with OS library. Half linking with the OS library, then communicating with hardware components. See, to communicate with hardware components, these programs, first of all, yes, have to link with OS library. After linking only, communication starts, communicating with the hardware. So every program has to link with OS library. Every program, maybe C program or Java program or C++ or Python, every program has to link has to link has to link with has to link with OS library has to link with OS library. So every program has to link with OS library before going to before going to run it here. So every program has to link these programs, first of all linking with OS library. Half linking with OS library, then the execution starts. So before going to run, first of all linking with OS library. Soft linking with OS library, then execution starts. That link may be statically linking or dynamically linking. Statically or dynamically. Statically, dynamically. That link may be statically or dynamically. Static link and dynamic link. The topic we'll discuss in Java. Java is an independent platform. Java is independent. Yes, I'll explain about this topic here. Yes, yes, maybe in next session getting. In the next session, how Java made us independent platform. How Java made us independent platform. That time we are going to discuss about this. Static link and dynamic link. Okay, suppose C and C plus a static linking. So that is platform dependent. See, Java and Python is a dynamically linking. Dynamically linking. So those are independent of platform. Dynamic linking is a independent of platform. Static linking is a platform dependent. Yes, this topic. Yes, I'm holding this topic. Later we'll discuss. Statically dynamic linking. Most important topic. This is statically dynamic linking. This topic. Yes, mostly getting Friday. Friday topic. Okay. Yes, just wait for some time. So in couple of days, getting the topic. Okay. So this is about OS. So what is operating system? It's a platform. Next, it's an interface. Okay, inside of OS is library. Okay, for communication purpose. Next, every program linking with OS library. So remember this third and fourth point. So third and fourth point, try to remember it. Okay, fine. See, this is today topic. Yes, about voice. Can we run any program without voice? No. Same that points here. Prepared in the document. Same as it is prepared. Nothing missing. Even single word is not missing. Same thing as it is there here. Okay. Next about voice. It's a platform. Next is interface. Same that all the 4 points. See, hardware layer on top of hardware, OS with library on top of it, applications of same thing. It's there in document. Just simply can follow documents. So I think it's clear. It's clear. Now Java. Come to Java. So what is Java? System software, application software. Tell me guys, anyone can you answer this? So what you understand from this? What is Java? Yes, Java comes as system software, application software. Hello. What is Java? System software, application software. Hello.
Application software.
Yes, Java is application software. Java comes under application. Java is a application software. Java is application. No, Java, how it is both? Java is application software. Okay, Java is not a system software. Okay, it's application. C language system software as well as application. C language, both. C language working like a system software as well as application software both here. C and C++. C and C++ can perform as system software and application software both. But Java is a purely application software. Java is application software. Java is application software. So let us move to application software. See, application software. In application software, there are two things. There is a front end, back end. In application software, front end softwares, back end softwares. In application software, front end, back end. So what is front end, back end? What is front end, back end? See, here this is web application architecture. So this web application means so application which is running on the internet. Application which is running on the internet is a web application. Application which is running on the internet is a web application. Okay. For example, Zoom is a web application. Zoom app, web application. Facebook is a web application. WhatsApp is a web application. Online shopping applications are web applications. Application which is running on the internet is a web application. Yes, in this application, yeah, there are two parts here. There's a front end and there's a back end. Front end, back end. So there's a front end, back end. So here it's a front end, back end. So front end, back end. So here there's a front end and there's a back end. Front end, back end. 1 second. So here there's a front end and back end. So front end. Yes, in web application there are two things here: front end, back end. Front end, back end. Front end, back end. Okay. So front end means is a browser environment. So front end is a browser environment. For example, here, for example, for example, yes, you guys today, yes, you filled some form, right? Some registration form. Yes, some registration form. So you are demo link, right? Registration form. Right? Yeah, this is front end. You fill some form, right? The browser environment form. So you can form field, right? So this form is a front end. So front end interacting with users, interacting with users. So here I'm user, right? I'm using Zoom application. I'm the user. I'm an end user. I'm end user of this application. Zoom application I'm using. So filling form, submitting that, right? So this is front end. This is front end. Browser environment is a front end. Suppose Zoom. Yes, Zoom application. See Zoom login. Okay. So Zoom. Yes, this all this. So it's a front browser environment is a front end. So browser environment is a front end. Is a front end. So front end interacting with users. So front end, the browser environment, front end. Right. Next back end. See in back end here. So front end browser environment is a front end. In back end, this application database. Back end application database. Application and database. Okay. So for example, front end. So this is a form, registration form, right? Registration form filled and submitted. What happens here? registration form filled and submitted. So once you filled and submitted here, submitted, simply data, the registration form data simply posting to backend. Okay, so front end data from the browser. So once you submit it, the data will be posted to application. At the backend, this application. So this application taking data and inserting database server, database, right? Okay. Now in this here, so who are working on the front end development, like who are using HTML, CSS, JavaScript, so maybe React JS, Angular JS. So who are working on these technologies is a front end developer. So who are working on all these technologies is a front end developer. Suppose who are working backend in backend database, here is database developer, maybe SQL, PL, SQL developers, database developers. Next is application developer, applications. This Java application, maybe .NET application, Python application, some whole application, Node.js, like there are different kind of applications here. Okay, so here this is, so here is a front end developer in back end application developer, back end database developer. Okay, so there are three roles. Front end developer role means UI developer, user interface, UI developer role. Next, application developer role, database developer role. There are three roles. In application development, there are three roles. Three roles. So front end developer role, application developer role, and database developer role. So there are three roles. See who are performing all the three roles, who are involving all the three roles is Java full stack developer. Suppose server side Java, if it is Java, then Java full stack developer. Suppose if it .NET using .NET full stack developer. So if it is Python, Python full stack developer. See all full stack developers, this is common. Front end and database is common. That UI and database is common. UI and database is common for all full stack developers. Okay, suppose server side using Java, that is Java full stack developer. If it is .NET full stack developer. Python full stack developer. So Node.js, the Node.js full stack developer, right? Okay, fine. So who are playing all three roles, who are performing, who are involving all three roles is a full stack developers. Okay, now Java comes here. In application development, Java comes here. Okay, Java comes here. See, JavaScript is different, Java is different. Both are not same. JavaScript is front end, Java is a back end. So where Java using here? Java. See Java. See Java. Java is a application software. Java is application software. In application software, there is a front end software and back end software. Where Java using? Java at the back end. So Java exactly backend. Java is a backend software. Java is a backend. Java is a backend. See, Java is a backend server side programming. Okay, to develop server side applications. See, client. Say front end is a client. Front end is a client. Back end is a server. Front end is a client. Back end is a server. Okay, so Java is a backend server side programming. Okay, so Java is a application software. In application, Java is a application software. In application software, it comes under what? Backend application software. Java is a backend application software. Java is a backend application software. Okay, fine. Now in this, yes, maybe front end backend. Maybe front end backend. There are language and packages. Language, some language using at the front end, some language at the back end. Okay, so front end language and back end languages. Front end, back end language. So what is Java? Language or package? Language. Java is a language. Okay, Java is a back end language. Java is a back end language. Okay, so Java comes under back end language. Now about language. Let us see about languages here. About language. It's about language. About language. Yes, what is a language? See, we are speaking many languages, right? In our daily life. Depends on person facing here, speaking different languages. Why? Why speaking all the language? Media of communication. Okay, see, I'm speaking English, right? To communicate about Java, to explain about Java, I'm using English. So English is a media of communication between you and me, right? Just it's a media of communication. It's a media of communication, right? Yes, come to software languages. Come to software. Yes, software languages. Sorry, software languages. Software languages. Software languages. Software languages. See, software language in software. See, computer. Yes, understanding some language. Computer understandable language. Computer understandable language. Yes, in software, computer understandable language. And next, user understandable language. We are understanding language, computer understanding different language. Computer language different, our language different. Our language is English. Like C program, we can understand it's English. Java program is like English. Python scripting like English. Those are English only here. User understandable language. User understandable. User understandable language. User understandable language. Okay, computer understandable language, user understandable language, user understandable language. Okay, right? So, what is computer understandable language? First, let us say about computer understandable language. See, computer understandable language depends on generation of computers. Yes, it depends. Yes, it depends. It depends on generation of computers. Generation of computers. Depends on generation of computers. Depends on generation of computers. Now again, one more question for you guys. One more question. Yes. How many generation of computers? How many generation of computers? Anyone can you answer this question? How many generation of computers? Anyone can you answer this question? How many generation of questions? Actually, you have to ask the question, but I'm asking questions here. Okay, reverse. I'm asking questions. Yeah, tell me guys. How many generation of computers? Anyone idea? How many generation of computers? No idea. How many generation of computers? Okay. Yes, there are five generations. There are five generation of computers. Five generation of computers. Just search in Google. Yes, online guess you have the searching facility, right? Offline guess means may not be, but you are online, right? Yes. Open your browser, search in Google. Okay. There are five generations. Five generations. Yes, first generation computer. So which is first generation computer? Vacuum tubes. Vacuum tubes. Vacuum tubes, right? Vacuum tubes. Yes, it's the electronic subject. Don't worry, guys. It's the electronic subject. Yes, vacuum tubes. Vacuum tubes. Second generation computer. Second generation. Yes, it's a transistor based. Transistors. Transistors based. So first generation is vacuum tubes based here. Vacuum tubes based. So second generation transistors. So transistors based. Third generation computer. Third generation. So what is third generation? IC based. IC based. IC based computers. IC means integrated circuits. Integrated circuits. Next, fourth generation. So what is fourth generation? It's a processor based. It's a processor based. It's a processor based. Now this is present generation. Presently we are using processor based computer. Presently. So fourth generation is a present generation. Presently we are using processor based. Right? Next fifth generation is a feature. Yes, what is feature generation computer? So what is feature generation computer? Anyone? Fifth generation. So next generation, fifth feature. It's a feature. Yes, someone saying. Yes, Harish. Yes, good. AI based computer. So what is AI based computer? I will explain today. I will explain. So this is feature generation. Feature generation. So AI is a feature generation. Okay, it's a feature generation. Okay. So first let us see. Yes, these all are old one, not necessary. Yes, processor based. Processor based. Okay. So processor based computer. Computer. Yes, understandable language. Understandable language. Understandable language. What is processor based understandable language? What is processor based computer understandable language? Binary code. is a binary codes. Binary codes. So binary code is something like zeros ones formats. Zeros ones formats. Binary codes. Binary code. So processor based understandable language is binary code. Binary codes. Okay, fine. Now let us say about AI based. So what is AI based computer understandable language? What is AI based computer understandable language? AI based computer understandable language is English. It can understand our English. AI based computer, it can understand our English. Okay. So what is exactly AI? Artificial intelligence. So what is artificial intelligence? What is artificial intelligence? So what is AI? So AI is a technology. AI is a technology to make machines. Machines, yes, machines working like a human being, like a human, right? Okay, so AI is a technology. AI is a technology to make machines so working like a human being. So without human intervention, yes, every task. So every task. So performing every task, performing performing performing, yes, every task or every work. So without human intervention, without human intervention, that is AI. Okay, I'll tell you some examples. Interesting topic about AI. Let me explain something about AI. See, AI machine. Suppose in your home there's a AI machine. Suppose you purchased one AI machine. Okay, that AI machine working like a human being. Okay, yes, if you say some instructions, yes, it can understand your English. AI machine can understand your English here, like a one of your family member. So that AI machine is a just like a family member. Whatever you say, it listen for your instructions. It can understand your English. AI machine can understand your English here. So whatever the instructions you are giving, it will, yes, it will take that instructions. It will work as per your instructions. Like for example, closing door. If you're asking to close the door, it will close the door. Okay. Suppose if you're asking to power off, yes, power off. Okay. Maybe power off, switch off, switch on. Next. So fan, power off, power on, washing machine, off on, like this, like a human being. That machine working like a human being here. Okay, next one more thing here. Yes, you can chat with AI machine. You can talk to AI machine. If he's saying some stories about your ancestors and about your life, if he's saying some stories here, AI machine will listen for your story and listen to your story and it will remember. Okay, so that AI based machine will take voice data and text data also, like a human being. See, you guys now listening to my topic, right? I'm explaining about all the software, right? You listening. AI machine also same thing exactly to listen here. It will take voice data. That AI machine will take voice data. Okay. Yes, voice data and text data also. See, you guys, so this is reading text data. It's a text data. Yes, you reading text data, right? Okay. Next, and also you listening to my topic, right? You listening as well as reading both, right? Listening and reading both. So means you taking voice data and text data, voice and text. AI machine also will take same thing here. AI machine will take voice data as well as text data. After taking voice data and text data, it will keep into memory. It will keep in the text data and voice data both. It will keep into memory. Keep into memory. After keeping into memory here, if you asking any question from this data, yes, you will answer simply. Okay. Suppose yes, you told about some story. You explained about some story. Okay, maybe story about your ancestors, story about some event happening outside. You explained about some story. AI machine will remember the story. If you're asking any question in that story, it will respond immediately. Like a human being. Okay, like a human being, right? So today explain many topics. Okay, you will remember this topic here. If I'm asking question, okay, if a topic covered here, you will answer respond immediately. Same AI mission is exact like human being here. Okay, so if you're asking some question, AI mission will take that mission. Sorry, if you're asking some question, some query, AI mission will take that query. That query is simply passing the backend language. What is backend language for AI machine? What is backend language? Backend language will process, will filter data and giving answer. So what's a backend language? Java, Python, R language. So behind of AI machine to process voice data, text data, to process the data, filtering data. Yes, question given. As per question, it has to filter the data. Answer it has to filter. For filtering purpose, backend using Java, using Python, using R language. Using this language, it will process the data and filtering data and getting answer and giving reply, right? Okay. See, suppose for example, chat GPT. When you submitted some question is chat GPT, what is that question go to chat GPT tool? Behind of tool, some programs running here. Those programs are Python scripting running, Java program running, R language. So those language will run here. Yes, we'll process it here and picking data from that. Okay, and submitting, right? That's it here. That is exactly A here. Okay, so AI machine, yes, working like a human being in your home. Yes, if any AI based machine is there here, yes, it will listen for all of your instructions. It will listen for your stories. It will remember. Yes, yes, any question, it will answer that. Suppose your question answer, if not available in data, what happens here? Yes, shows that something wrong, something wrong, right? Suppose you learning Java, right? Suppose attending interview, suppose asking some question. Yes, if you don't know about it here, if you don't have data in your mind, then what if you can't respond, right? Same AI based machine also. Yes, if AI machine is having that data, it respond. Otherwise, you won't respond. Okay. See one more example of AI based machine here. See one example, best example is Alexa, right? In your home, this is Alexa. Alexa is also AI based. Alexa is a A, but it's a weak AI. Alexa is a weak AI, not is a strong AI. Alexa is a very weak. It's not a strong AI. Okay. Yes. Tesla car. One more example. Tesla car is a strong AI. It's very strong in AI here. Tesla car. So Tesla car, yes, is a driverless car. Driverless car. Driverless car. Tesla car in USA. Okay. Yes, in India. Yes, they are planning to launch in India also shortly. Elon Musk. That guy Elon Musk is planning to launch in India. We got driverless car. So this driverless car. So whatever he says instructions. So this Tesla car simply integrating with your mobile. That car integrating with the mobile here. So from the mobile you can operate this Tesla car. Okay, suppose if you want to take out of the parking, you can take out of the parking here. In mobile, say that instruction. You talk in mobile. That mobile app will take that instruction, pass into the car. Car will come out of the parking, right? So for example, pickup. Suppose if you define some route, if you say some route here as per route, it will go to that location here and picking and dropping. So picking maybe whatever it's picking here, maybe items picking, maybe human being, yes, maybe something. Okay, right? Pick up and drop. So car will take care of that. Okay, right? So without driver, it will take care of everything. So so in place of driver, simply car will take off driver here, right? Will take care of that driver activity, right? Okay. So Tesla car, best example. Okay, right? Not only Tesla car here, like there are many examples. Okay, health monitoring machines, health monitoring, health, yes, health monitoring. Okay, health monitoring. Yes, AI-based health monitoring machines. Suppose wristwatch. Nowadays, many AI-based wristwatches are coming here. Wristwatches. I have that wristwatch. Okay, that will monitor my health. Wristwatch. Okay, yes, wristwatch. So once wearing your wristwatch here, yes, it will monitor your health here. Yes, walking. How many steps walked today? It shows at the end of day. Okay, how many steps you have to walk in this hour? How many steps you have to walk? Next, what is your heart beating? And all this it will monitor. That is AI based. That is also AI based. AI based, right? So like a doctor, yes, even it give the advice also. Advices. Advice like suppose heartbeat is more than, yes, more than actual, it will alert you. Your heart is beating more than that. Maybe heart strokes and all alerting you. So in as everything it will alert you. So like a doctor. So that AI based mission. using for health monitoring. That is like a doctor advise you. Correct? Not only health sector, yes, even manufacturing industries. In manufacturing industries also we can see AI-based machines here. So like a human being, yes, like a human, yes, it works here. So like a workers, AI-based machine will work. Okay, right? Manufacturing, okay, maybe constructions. Okay, yes, everywhere, wherever human being working, there we can see AI-based machines. So AI-based machine working like a driver, working like a worker, yes, like working like your servant, working like a doctor, working like a scientist, so working like an engineer, yes, all the roles. AI machines will perform all of our roles. Even AI-based machine will work like a software engineer also. Okay, AI machines even work like a software engineer also. Okay, that programs, pre-developed programs, it will take it will integrate and developing applications. Okay, so wherever human being intervention is there here, there all AI-based machines will work. That is exactly AI here. Okay, exactly, right? So AI-based machine working like a driver is working like a scientist, working like engineer, working like a doctor. Okay, so working like a helper and all that here. That is exactly AI-based machines. Okay, so wherever human is there, simply AI machines will work. Okay, right? That is about AI. Correct? Yes, here AI advantage. So what is the advantage of AI here? Yes, within short time work finishing here. Short time, within short time, yes, finishing your work. Within short time only finishing your work. Okay, right? Next, yes, with less expenditure also. Because yes, here need not to, is not necessary to yes hire human resources. Not necessary. Less expenditure. Less expenditure. Okay, right? Next, work transparency. So work transparency. So work transparency. Right? Like this, work transparency. Okay. So like this, there are yes, work transparency. So like this, there are many advantages. Okay, there are many transparency. So there are many advantages with AI here. Yes, this is having disadvantage also. What is disadvantage? A mean disadvantage. Yes, first disadvantage. Yes, human being getting lazy. Yes, getting lazy. Yes, human being getting lazy. Okay, lazy. Right? Yes, apart from other disadvantages. Other disadvantages. See, yes, our thinking skills reduced. Everything by the AI, right? So automatically thinking skills. So thinking skills reducing. Okay. So thinking skills reducing, right? Thinking skills reducing. And next, one more dangerous is everything under the control of AI machines. Yes, everything under the control of AI machines. See, now we are controlling machines, right? As per our instructions, yes. As per our instructions, machines are working. As per our instructions, okay, machines are working. So all machines and everything under the control of human being, right? But in future, once AI comes here, everything under the control of machines. As per machines, we should work. Suppose if you're doing something wrong, AI machine says that it's wrong something here. So under the control of AI machines, in future, everything is under the control of AI machines. AI machines. So reason is here. AI machine is more intelligent. AI machine is more, yes, is intelligent, more intelligent than human being. More intelligent, more intelligent than human. Human, right? So these are disadvantages with this. Next, one more thing here. Cases. Many are says that if AI comes, loss of many jobs. No chance. No loss of many jobs. Many jobs. Reason I will tell you. Now currently world population is 800 crores. Currently world population is 800 crores, right? See, previously 20 years ago, 20 years ago means 90s period. In 90s period, world population just only 300 crores, right? 90s, not even, yeah, 300 crores. In 90s period, world population is 300 crores, right? Now it's reached to 800 crores. Now present reached to 800 crores, right? Okay. Yes. Serving 300 crores of people is very simple than 800 crores, right? So world population needs to 800 crores. To serve 800 crores of people here, yes, that human efforts. Okay, apart from human efforts, technology we are using. Okay, technology is available. Yes, like latest technologies, like mobiles. Okay, next chatting application, many things, many technologies we are using, right? Even many technologies and human efforts and everything using here. Yes, unable to meet the requirements of 800 people, 800 crores of population, right? Yes, unable to meet the requirements of this. Even it's becoming later. Even technology is there, human efforts is there, everything is there. In 90s period, don't have this much of technology. In 90s period, don't have this much of technology. Even don't have technology that time, able to serve all people because of population is very less. But now population is 800 crores. Yes, to meet the requirement of 800 crores of people here, not only human efforts, technology help also necessary. Technology help also necessary. Okay, right? Fine. That is present scenario. Suppose after 10 years, AI will come to picture. After 10 years, how much world population? Yes, maybe 1200 crores population. After 10 years, 1200 crores of population, right? Yes, to serve 1200 crores of population, yes, many service, many technology, advanced technology required here. Very advanced technology, AI. Apart from AI, human efforts also required. Human efforts required and AI also required. Otherwise, cannot serve 1200 crores of people. Very fast and accurate work required. Fast work, accurate required. Okay, fast work and accurate work and transparency. Fast work, accurate and transparency. To meet all that here, yes, human efforts not enough. We need AI also. Even AI comes, no loss of jobs. Don't worry, guys. This is by analysis. Okay. Yes, most of the business analyst says that loss of software jobs, loss of other jobs, that is wrong. Okay. Yes, no loss of jobs. Because to meet the requirements of this 1200 crores of people, yes, human efforts not enough. Human efforts not enough here. For that, we need help. That is nothing but AI. AI with human efforts. AI with human efforts can meet the requirements of 1200 crores of people here. So that's the reason no chance of loss of jobs. No worry about this one here. Even AI comes, jobs as is will be there. Because lot of population that after 10 years, 1200 crores of population to meet the requirements of 1200 crores with accuracy, with quality, with fast, okay, with less cost, okay, next transparency. There are many factors. Okay, right? So you can with many factors meeting requirements of 1200 crores of people here. Not only human efforts, we need AI also. This technology is not enough. No present technology. See, 90s period technology different. Nowadays technology different, right? 90s period technology is not yes enough to meet the requirements of present generation, right? Yes, now present technology yes is not enough to meet the requirements of 1200 crores of people. Okay, 90s period only 300 crores. That time technology is not enough to meet the requirements of 800 crores. So for that new technology, no present technology and human efforts serving this 800 crores, right? In future after 10 years, 1200 crores, right? To meet the requirements of 1200 crores of people here, present technology is not okay, it's not sufficient, it's not enough. We need advanced technology. That advanced is AI. With AI only, using AI plus human efforts, we can serve this much of people in the world. I think you understand that is analysis. Okay. Yeah, that is analysis. So even AI comes, no loss of jobs. Human efforts also required compulsory. No loss of jobs. Don't worry about no threat from the AI. I'm sure. Okay. Same thing after 10 years. If you meet somewhere, just you tell me. Okay. Most or even experts are they says that but AI comes loss of jobs. No, no chance. Okay. After 10 years, if you meet me somewhere, you will say same point. No loss of jobs. Okay. So after 10 years, to meet the requirements of that much of population, yes, apart from human efforts, we need very advanced technology, AI required. Okay, now current technology, what are the technology we are using? This technology is not enough after 10 years. Okay, so present technology is not unable to meet the requirements of people after 10 years. So after 10 years, we need some new technology. That new technology, AI. So AI with human efforts, then meeting the requirements. Okay, so guys, no threat from the AI, no loss of jobs. Don't worry. Okay, right? Yeah, fine. So this is about AI. Okay. Yes, next year. No, present. Let us see about processor-based computer. So processor-based computer understandable language is binary code. It's a binary code. Binary code. Yeah, this is called as low-level language. Low-level language. Okay. See, computer understandable language is a low-level language. User understandable is a high-level language. So languages are low-level, high-level language. There are two things in software. There are two things here. Low-level languages, low level languages, low level languages. Second one, high level languages, high level languages, low level language and high level language, low level language and high level language. Low level, yes, low level, it's a system understandable language. Yes, it is a system understandable, it's a system understandable, it's a system understandable, it's a system understandable language, it's a system understandable language. Yes, here system is what? Low level language is a system understandable language. Yes, system means processor. System means processor. Okay, it's a processor understandable language. Processor. The processors like 8085 and 8086. Okay, so before 90s we have 8085. 90s periods onwards. 90s onwards we are using 8086. Now presently 8086. Okay. Yes, it's understandable language is binary codes. Okay. Yes, system understandable language. Processor understandable language. Okay, processor understandable language. Yes, processor understandable language. Understandable language. Understandable language. Language in the form of binary code. It is in the form of binary codes. Binary codes. Binary codes. Like zeros ones format. Zeros ones format. Zeros and ones format. Processor understandable language. Right? Yes, it is called as machine language. Yes, it is called as machine language. It is called as machine language. It is called as machine language. So it is called as machine language. Yes, low level language, it is called as machine language. It is called as machine language, right? Next, high level language. Next, about high level language. High level language, yes, it's a user understandable language. Yes, it is a user understandable. It's a user understandable language. It's a user understandable language. Yes, it is like English language. User understandable like English language. Like English language. Like English language. It's like English language. English language. High level language examples. Java is high level language. Java program looks like English. Java is like English. Yes, C and C++ are like a English. The high level language. Python is a high level language. Some HTML. Okay, all their high level language. Yes, one more question. I'm asking one more question. One more question. Yes, which is first developed? Which is first developed high level language? Which is first developed high level language? Anyone can you answer this? Which is first developed high level language? Yes, good, Harish. C language. C language. C language. C language is a first developed high level language developed by who is the author of C language? Who is the author of C language? Harish. Dennis Ritchie. Dennis Ritchie. Yes. Dennis Ritchie is the author of C language. Yes, it's a first developed high level language. In the year 1972. Dennis Ritchie. Then is which in the year 1972. 1972. See, before 1972, we have the machine language and assembly language. Low level language, machine language, assembly language. In 1972, C language was developed. So this is high level language, C language. First C language, high level language, C language. After C language, next C++. After C++, Python. After Python, Java. Yet that software history I will tell you later. Yes, one day I will explain about that history, software history. Since 1945 to today, since 1945 to today, what was happened in software history, I will tell you. 1945, initially machine language, assembly language. See that history, year-wise history I will explain. See, since 1993, I have the software awareness. 1993, my engineering started. 97 completed. So my work started in 1997. So since 1993, I have the software awareness. I will tell you. So what is that software history? What was happened in the software markets? I will tell you. Okay. Yes, one day I'll explain about this one. One day I will take this session. Yes, it's their session. Okay. Yes, in Java we have the OOPS concept. Before going to OOPS concept, yes, the software history, what was happened in the software industry. Okay, that all that I will explain very clearly. One day I will explain 90-minute session. This is okay. Software industry, what was happened is since 1993. I have seen live 1993. Okay, since 1993, I have seen everything live. Before 90s, nothing is there. Just only C language, C++, Unix is there. C++, Unix. Yes, in 90s period, suppose 93, that 90s period, if you know the C and Unix, getting job immediately. Not necessary to learn all the technologies. Just C language basics enough, getting software job. Okay, C language basics, Unix basics enough, getting job easily that time. Okay, but that time we don't have this method of opening software. Rare case. So that time computer engineers are very rare case. Okay, fine. So this topic we'll discuss one day. Later I'll explain. Okay. So which is first developed high level language, C language. Okay, fine. See, high level language to low level language. See, high level language like a Java program, C program, C++, all their high level languages, right? High level languages. Yes, high level language to binary code means low level language, system understandable language. So programs, C program, C++, Java, these are high level languages. High level language. This high level language program has to convert into binary codes. High level language to binary codes. So which one will convert into binary codes? Binary code is system understandable language. Every high level language program, maybe Java program, C++, all the programs have to convert into system understandable language. Yes, system don't know about Java. Your computer don't know about C program, C++, Java, Python, these things here. So someone has to convert. Someone has to convert from this high level language to binary code. Binary code, system understandable language. So which one will convert from high level language to binary codes? Tell me guys, anyone? Which one will convert from high level language to binary code? Harish, come on. Which one will convert? Yes, compiler, correct. Either compiler, yes, compiler, either compiler or interpreter. Either compiler or interpreter. Either compiler or interpreter. Either compiler or interpreter will convert from high level language to binary code. High level language to binary code. So next our topic is about compiler and interpreters. So compiler and interpreter. Next topic is about compiler and interpreter. Just wait. Okay, wait. See today topic. Just wait for 2 minutes. So this is today topic. Yes, all of this is prepared here. See, software language, computer understandable, user understandable. See, generation of computers, that 5 generations prepared here. Okay. Yes, about low level language, about high level language. Yes, very clearly prepared in document. Okay, right? So next topic is about interpreter and compiler. So next topic is about interpreter and compiler. Okay. Yes, next topic about interpreter and compiler. Yes, anyone doubt here from today's topic? Yes, you guys, Are you understanding clearly? Are you understanding clearly or feeling any faster?
It's understanding.
Yes, is it fine, right? It's clear, right? See, generally my topics are very clear and like a spoon feeding, everyone can understand easily here. Okay, slowly I'll explain. Okay, I think this base is okay. This base is okay, right? See, every day my topic is like this. I will type in the notepad. Whatever things I'm saying, explaining, same thing I'll type in the notepad here. Okay. Suppose if I'm typing in notepad, you can understand very clearly. Okay. It's a visualization. Visuals you can remember forever. Simply just I'm talking means you can't remember. If simply I'm talking means you can't remember. Okay. But here I'm typing. Every topic I'm typing like this. So that you can understand clearly and you can remember forever. Okay. Yes.
Yes.
Still any doubts, guys?
No.
No